best way to understand the impact of individual risks or risk categories on overall risk results is through tornado charts. Otherwise, tornado charts help prioritize which risks are important and which are not so important in quantitative prioritization. From this point of view, tornado charts are perhaps the most important charts in risk management, as they allow to prioritize scarce management resources, time, money, among the total range of project risks that could appear. Tornado charts are so called because they show the longest bars at the top, and as you go down, the bars are shorter, forming a kind of a funnel. The single bird's eye view of a tornado chart allows the analyst or manager to obtain a quick conceptualization of which are the most relevant risks to manage, control, mitigate in a project. There are several types of tornado charts. The one used here is the linear or Pearson correlation coefficient. In general, this tornado chart displays the relative hierarchy of one input versus another by comparing the results of all the input variables over the analyzed output variable. For each input variable, the length of a bar indicates the linear correlation coefficient between the output or result variable and the input variable measured by this index, which ranges from -1 to +1. In statistics, Pearson's correlation coefficient is a measure of linear dependence between two quantitative random variables. Pearson's correlation is independent of the measurement scale of the variables. In a less formal way, we can define Pearson's correlation coefficient as an index that can be used to measure the degree of relationship of two variables as long as they are both quantitative and continuous. A tornado chart of linear or Pearson regression coefficients shows the magnitudes of the bars scaled or normalized by the standard deviation of the output and the standard deviation of that input. In other words, this number shown on the bar is not expressed in actual dollars or any other unit. Select Total Risk on the Outputs tab and click on the tornado icon on DT Simulators ribbon. You will see a tornado chart window popping up where the correlation tornado is shown with individual risks. Of the 20 bars that, as a maximum, are shown in this tornado, the risk availability of building materials is the one with the highest magnitude of 0.59 as its linear or Pearson correlation coefficient. The formal interpretation is roughly the following. For total risk, the input variable availability of building materials has a correlation coefficient, also called standard beta, of 0.59. This means that for each unit of increase in the standard deviation in availability of building materials, the total risk, that is, the output, will increase by 0.59 standard deviations of the total risk amount. In other words, both the standard deviations of the input and the output are needed for a complete interpretation of this coefficient. Admittedly, these types of formal descriptions are difficult to communicate to decision makers. In the next lesson, when interpreting third-level graphs or scatter plots, this idea of how to interpret these types of tornadoes will become clearer. For now, what is clear is that of the 20 risks present, the 3 risks that have a greater impact on the total risk of a project are: number 1, availability of construction materials with a coefficient of 0.59. Number 2, natural disasters with a coefficient of 0.50. Number 3, extreme weather conditions with a coefficient of 0.43. It is important to clarify that each of these coefficients should be interpreted independently and individually with respect to the output variable in question, in this case, total risk. The coefficients do not have to add 1 unit to each other or anything like that. Its magnitude is just an expression of what is the degree of association, regardless of the magnitude of the correlated variables between them in a linear way. Let us now go back to outputs for a moment, and having already identified that the logistics risk category is the one that has the greatest impact on total risk, select Logistics Risk and click on the histogram icon to view its respective histogram. Having selected this graph, notice how obviously the shape of the histogram and the statistics change. After closing this chart window and keeping your cursor on total risk now, we click on the tornado chart icon. As we have chosen a category, logistics risk, we can now interpret its chart. Of the 8 individual risks that make up the category of logistics risk, it is precisely availability of construction materials, the individual risk that has the highest correlation index with a magnitude of 0.88. This, in fact, is entirely dominant over the other risks. In other words, there's only a 12% of the variability of the logistics risk that is not being explained by the variability of the risk of availability of construction materials. It will be the remainder of the 7 remaining risks that could residually explain the variability of the logistics risk pending explanation. Scatter plots, or third-level charts, help us understand these correlation ideas a little bit better. Remember that a PNG file has been saved with the name tornado.png on the same directory where the workbook file resides. You can use this file to insert it into your documents or presentations.